The question here is, if A is an obtuse angle whose sine is 5 by 13 and B is an acute angle whose tangent is 3 by 4. Without using tables, find the value of. Now, given A is obtuse, sine is 5 by 13. So sine A is given to be 5 by 13, where A is obtuse. Obtuse means what? It is in the second quadrant. A is in the second quadrant. Greater than 90 degree but less than 180 degree. That is the definition of obtuse. Okay. Also, what is given to you here? That B is an acute angle and tangent of the angle is 3 by 4. Where B is acute. That is, B is in the first quadrant.
Good morning, sir.
Good morning. Okay. You need to find out the value of sine 2B and tan A minus B. Now, so you know that sine 2B is equal to 2 sine B cos B from multiple angle formula, right? So do you know sine B and cos B? You don't know. But what you know is tan B. So you can find out from tan, you can find out sine B and cos B. By many ways, by drawing triangles also you can find, as you had done in class 9. But the better way that I taught you, if you remember, is tan B is 3 by 4. So you can write sine B by cos B is 3 by 4. That means you can write sine B by 3 is equal to cos B by 4 is equal to plus or minus square root of sine square B plus cos square B divided by root over of 3 square plus 4 square, right? Which is equal to plus or minus 1 by 5. That means sine B is equal to what value should I take? Plus sign or minus sign? If you see, B is in the first quadrant, right? That means sine B is 3 by 5. And how much is cos B? Cos B is also in the, B is in the first quadrant. Therefore, cos B must also be equal to 4 by 5 since B is in the first quadrant. Hence, sine 2B is equal to 2 sine B cos B, which is equal to 8 by 25. No, this is 1 by 5 and 4 by 5 we have got, no? Okay, so this is equal to 24 by 25. Okay, so that is the value of sine 2B. Second question. We need to find the value of tan A minus B. See, tan A minus B, what is the formula for tan A minus B? Compound angle formula. Tan A minus tan B divided by 1 plus tan A tan B. This is the compound angle formula for tan A minus B. Now we see what we know and what we have to find out. Tan B is already we know, right? So this we know, tan B we know. Only point is to find tan A. How to find tan A? We have to find tan A from sin A, which again you can do by your triangle method. Okay, or better method is you can use identities also. So we have cosec square A is equal to 1 plus cot square A. Why cosec square I have used? Because I know sine. Okay, that is why I am using this identity. Cosec square is equal to 1 plus cot square. That means cot square A is equal to cosec square A minus 1. And how much is cosec square A? If sine A is 5 by 13, cosec square A must be 13 by 5 square. Just the reciprocal minus 1. So you get a 169 divided by 25 minus 1. 169 minus 25 divided by 25, which is equal to 144 divided by 25. That means how much is cot A? Is equal to, now see, when we are taking square root of this, you have to determine the sign, right? So for the sign, you have to check which quadrant is which A is in. A is obtuse. That means A is in the second quadrant where cot is negative. So we take the negative sign. You understood why I'm taking the negative sign?
Yes, sir.
So minus 12 by 5. Okay, that means tan A here is minus 5 by 12. So now we have got the value of tan A, and tan B we already knew. Hence tan A minus B is equal to tan A minus tan B. How much was tan B? 3 by 4 divided by 1 plus tan A into tan B. And that is the value of tan A minus B. You can simplify this value to find this to be minus 8 by 9. Okay, we move on to the next problem then. Number 8. Given that cos A by 2 is equal to 12 by 13, calculate without using table the values of sin A, cos A and tan A. So the only value that is given to you here is cos A by 2 is equal to 12 by 13. You need to find the value of sin A, cos A and tan A. Let's first find out sin A. Which multiple angle formula should you use for sin A? Sin A, you know, is 2 sin A by 2 from some multiple angle formula, cos A by 2, right? Cos A by 2 we already know, but we don't know sin A by 2. So let's find out sin A by 2. So therefore, sin A by 2 is equal to plus or minus square root of 1 minus cos square A by 2, which is equal to plus or minus square root of 1 minus 12 by 13 square. Okay, which is equal to plus or minus square root 1 minus 144 by 169. So you get this as plus or minus 5 by 13. Hence, what is sin A? Put the values here in this formula. 2 sin A is plus or minus 5 by 13. Sin A by 2 and cos A by 2 is 12 by 13. So what is the value of sin that you are getting? Plus or minus 120 by 169. Okay, that is the value of sin A. Now we need to find out cos A. Okay, so how do you find out cos A? Now see, cos A, you will be tempted to find it out by cos square A, because you'll say that you know sin A, so therefore you'll use cos square A is equal to 1 minus sin square A, right? Isn't it? But the problem is, but when you find cos A, you will have to take the square root of this, right? So which sign are you going to take? That is the problem here. So therefore, a better way of finding out here is by using multiple angle formula where there is no problem with the signs. So we have, what is the multiple angle formula that we are going to use? Some multiple angle formula. Cos A is equal to 2 cos square A by 2 minus 1. If you remember this multiple angle formula, right? Multiple angle, sub-multiple angle formula for cos A is cos A in 2 cos square half of this angle minus 1. Now you can put the value. The value of cos A is 12 by 13 square minus 1. And you can find this out to be 119 by 169. If you had used cos A is equal to plus or minus root over of 1 minus sine square A, because we did not know which quadrant A is in, so therefore we would be in a fix to choose the sign, which sign to choose. Therefore, if you use this submultiple angle formula, then you will be able to very easily uh, not be in a fix whether to determine what sign, because you're only getting a positive sign here. Okay. And finally, tan A. Tan A is sin A by cos A, as simple as that. So this is plus or minus 120 by 169, and cos is 119 by 169. This cancels, so you get plus or minus 120 by 119, and that's your answer for tan. Any question?
No, sir.
We'll move on to the next problem, which is question number 9. Question here is given that tan x is equal to 12 by 5, cos y is minus 3 by 5, and the angles x, y, and y are in the same quadrant. That means x and y either in the first quadrant or second quadrant or third quadrant or fourth quadrant. But whatever quadrant, they are in the same quadrant. Okay, so given here tan x is equal to 12 by 5, cos y is equal to minus 3 by 5, where x and y are in the same quadrant. Now, if x and y are in the same quadrant, if you see tan is positive, right, and cos is negative, in which quadrant is tan positive and cos negative? Can you tell me in which quadrant tan is positive and cos is negative? Second quadrant.
No,
In
sir.
the,
Third quadrant.
in the third quadrant, tan is positive. Yes, third quadrant, exactly. Yes, in the third quadrant, tan is positive and cos is negative. In the second quadrant, tan is positive and cos is also negative, I think. Yes, it's so the possibility is that either both the angles are in the second quadrant or both the angles are in the third quadrant, right? So question here is calculate without using tables the value of sine x plus y. Okay, so let's see how to calculate sine x plus y from these two. That is, you can write here x and y are either in the second quadrant or third quadrant. Okay, so either both are in second quadrant or both are in the third quadrant. First one, sine x plus y. Compound angle formula for sine x plus y. Sine x cos y plus cos x sine y. Right? So what do we know here? We know cos y. So we know cos y here. What we don't know is, we don't know sine x, we don't know cos x, we don't know sine y. So let's find out. First, let us find out sine y. Square root 1 minus cos square y. Now the question is, which sign should you take? X and y are in the same quadrant, right? So write a plus or minus, and here also plus or minus 1 minus cos square y. Plus or minus 4 by 5 we'll get. Okay. Now we'll see, we'll determine the sign a little later. Let's keep it at plus or minus. Okay. So sine y we have got. How about sine x and cos x? We can get from tan x. Tan x is equal to 12 by 5. That means you can write this as sine x by 12 is equal to cos x by